Good morning, students. Now, the next part of chemical kinetic is zero order reaction, integrated rate law for zero order reaction, and unit of zero order reaction. So, definition of zero order reaction. What is zero order reaction? Derive integrated rate law for zero order reaction, and what is its unit? Now, the definition of zero order reaction. The reaction in which rate is independent of reactant concentration are called zero order reaction. The reaction in which rate is independent of the reactant concentration are called zero order reaction. Now the integrated rate law for zero order reaction. Consider the zero order reaction A gives P. This is a zero order reaction. Now for this reaction the differential rate law is given by rate is equal to minus dA upon dt. It is equal to K into concentration of A0, and the concentration of A0 is equal to 1 because for zero order reaction, rate of reaction does not depends on concentration of any reactant. So that's why concentration of A0 is equal to 1. So therefore rate is equal to minus dA upon dt is equal to K into concentration of A0. It is nothing but K. This is equation number 1. Now rearrangement of equation 1 we gives on rearranging equation 1 we get dA is equal to minus k dt because a0 is equal to 1. Okay, integration of this equation between the limits. Now integrating this equation, taking limits a is equal to a0 at t is equal to 0 and a is equal to at at t is equal to t. Integration of this equation between the limits a is equal to a0 at t is equal to 0 and a is equal to at at t is equal to t gives integration. Symbol of integration here, symbol of integration it is given a0 to at dA concentration d into concentration of a is equal to minus k into integration from 0 to t dt. Okay, so integration of dA is a. So concentration of a limits a0 to at and integration of dt is t. Okay, so therefore a0 to at is equal to minus k t 0 to t. Now by donating the limits we get at minus a0. By donating the limits we get at minus a0 is equal to minus kt. Okay, so hence kt is equal to a0 minus at. So kt gives a0 minus at and the unit of zero order reaction is the unit of rate constant for zero order reaction is mole per decimeter cube per second. This is the unit of rate constant for zero order reaction. So what is the unit of rate constant for zero order reaction? Mole per decimeter cube per second. Okay, this is zero order reaction. Now derive the expression for half life of zero order reaction. What is the half life of first order reaction? T half is equal to 0.693 upon K. This is the half life for first order reaction. Now the half life for zero order reaction. Derive the expression for half life for zero order reaction. Okay, or show that the half life of zero order reaction is proportional to the initial concentration of reactant. Half-life of zero order reaction depends on initial concentration of reactant, and half-life of first order reaction is independent on initial concentration of reactant. So show that the half-life of zero order reaction is proportional to the initial concentration of reactant. Okay, now what is the answer? First of all, the rate constant of zero order reaction is given by equation. What is the rate constant? K is equal to, this is rate constant, Kt is equal to A0 minus At. So therefore what is K? K is equal to A0 minus At upon T. Okay, this is equation number 1. Now using the conditions T is equal to T half, At is equal to A0 by 2. This is T half is known as half life period. Now using these conditions T is equal to T half, At is equal to A0 by 2. Equation 1 becomes, by substituting these two values in equation 1 we get, that is K is equal to A0 minus A0 by 2. K is equal to, this is the equation, by substituting the value of half-life period and concentration of At. What is At? At is equal to A0 by T, and what is T? T is equal to T half. So therefore K is equal to A0 minus A0 by T divided by T half. Okay, so therefore By cross multiplication, we get 2a0 minus a0 divided by 2. 2a0 minus a0 divided by 2, divided by 2. So, whole divided by t half. Okay, whole divided by t half. Now, we get, now simplification, the final equation gives k is equal to a0 by 2 t half. K is equal to concentration of A0 divided by 2 T half. Therefore, T half, we have to determine T half. So, therefore, T half is equal to A0 divided by 2K. Okay. Hence, half-life of zero order reaction is directly proportional to the initial concentration of reactant. This equation indicates that half-life period for zero order reaction is directly proportional to the initial concentration of reactant. So, this is the expression for half-life period for zero order reaction. Okay. Now, next question, how will you represent zero order reaction graphically? How will you represent zero order reaction graphically? So, the rate law of zero order reaction is given by, what is rate law? Rate law. From rate law, the concentration of AT, it can be given as AT is equal to minus KT plus A0. This is the rate law. From rate law, the equation is obtained as AT is equal to minus KT plus A0. Here, concentration of AT represents Y, minus K represents M, T represents X, and A0 represents C. Okay. So, which is straight line given by this equation is of the type y is equal to mx plus c, and it is a straight line, and when we plot a graph of AT versus time t, a straight line graph is obtained with negative slope. When a graph of concentration of A at time t is plotted against time, it gives a straight line with a negative slope. So, this is the graphical representation. Okay. So, AT versus T for zero order reaction, this is a graphical representation. Now, give two examples of zero order reaction. Zero order reaction, the reaction in which rate does not depends on concentration of any reactant. So, first most important example is photochemical reaction between hydrogen and chlorine to form hydrogen chloride. Photochemical reaction, when H2 gas reacts with Cl2 gas in presence of ultraviolet light, it gives hydrogen chloride, twice of HCl. This is an example of zero order reaction. Now, टेक्स्टबुक मध्ये काय एक्झाम्पल दिले बघा, डिकम्पोजिशन ऑफ nitrous oxide in presence of platinum catalyst. Nitrous oxide means laughing gas. Nitrous oxide, it is known as laughing gas, and it is the chemical formula of nitrous oxide is N2O. So, twice of N2O in presence of platinum gas, it decomposes to produce twice of N2 plus O2 gas. Nitrous oxide produces dinitrogen gas plus dioxygen gas. Okay, this is the first example of zero order reaction. Now, second example, the catalytic decomposition of phosphine, pH3. Phosphine means pH3 on hot tungsten at high pressure. This is the example of zero order reaction. Second example of zero order reaction. Now, next question, the decomposition of ammonia on platinum metal is a zero order reaction. Why? The decomposition of ammonia on platinum metal is a zero order reaction. Explain why it is a zero order reaction. Because decomposition of ammonia on platinum wire is represented as twice of NH3 gas gives N2 gas plus 3H2 gas. Decomposition of ammonia on platinum plate is represented as follows, that is twice of NH3 gas gives N2 gas plus 3H2 gas. The metal surface gets platinum's a metal surface, the metal surface gets completely covered by layer of ammonia. In this reaction, the metal surface of platinum gets completely covered by layer of ammonia molecules. The number of NH3 molecules attained on platinum surface is small. The number of ammonia molecules the number of ammonia molecules attached on platinum surface is small compared to ammonia. So, as a result, most of the ammonia molecules remains as gas and do not react. So in this reaction, most of the ammonia does not undergo decomposition. Most of the ammonia does not undergo decomposition because most of the ammonia gets covered on the platinum surface. So that's why it does not undergo decomposition. And because of that, rate does not depends on concentration of ammonia. So therefore, the molecules present on the metal surface only react. The molecules present on the metal surface only react means only a small amount of ammonia molecules undergoes decomposition. Okay, so therefore the rate of reaction is thus independent of the total concentration of ammonia and remains constant, and because of that the decomposition of ammonia is a zero order reaction. Okay, the decomposition of ammonia is an example of zero order reaction. Now next question, what are pseudo's first order reaction? Give example. What are pseudo's first order reaction? Give one example and explain why it is pseudo's first order. Why it is pseudo's first order reaction? Pseudo's first order reaction means the reaction in which molecularity of the reaction is more than 1, but the order of reaction is 1. Molecularity of the reaction is more than 1, but the order of reaction is 1. This reaction is known as pseudo's first order reaction. So definition, पुस्तकामध्ये वेगळी डेफिनेशन सांगितले, मी वेगळी डेफिनेशन सांगितली. दोन डेफिनेशन मी वेगळ्या सांगतो. द रिॲक्शन इन विच, पहिली डेफिनेशन काय आहे? द रिॲक्शन इन विच मॉलिक्युलॅरिटी ऑफ द रिॲक्शन इज मोर दॅन 1 बट द ऑर्डर ऑफ रिॲक्शन इज 1 इज नोन ॲज Pseudo's first order reaction. Or second definition, the reaction in which one of the reactant present in large excess, the reaction in which one of the reactant present in large excess shows order different from actual order. It is known as Pseudo's first order reaction. The reaction in which one of the reactant present in large excess shows order different from actual order. It is known as Pseudo's first order reaction. Okay. मग आता टेक्स्टबुक मधली डेफिनेशन काय बघा. Certain reactions which are expected to be of higher order. Certain reactions which are expected to be of higher order follows the first order kinetics. Such reactions are said to be Pseudo's first order reaction. Certain reactions which are expected to be of higher order follows the first order kinetics. Such reactions are said to be Pseudo's first order reaction. Okay. Example, hydrolysis of methyl acetate. Consider the hydrolysis of methyl acetate. Methyl acetate means CH3COOCH3 plus H2O liquid gives CH3COOH plus methyl alcohol. Means methyl acetate on hydrolysis produces acetic acid plus methyl alcohol. The rate law for this reaction is, या reactionचा rate काय येईल? Rate law, rate is equal to K dash into concentration of CH3COOH, K dash into concentration of CH3COOCH3 into concentration of H2. Now the explanation. The reactions was expected to follow the second order. In this reaction, how many reactant molecules are there? 2 reactant molecules are there. First one is methyl acetate and second one is water. 2 reactant molecules are there. So that's why molecularity of reaction is 2. But in this reaction, water is present in large excess. या रिॲक्शनमध्ये वॉटर कसा आहे? लार्ज एक्सेस आहे. आणि द रेट ऑफ रिॲक्शन डज नॉट डिपेंड्स ऑन कॉन्सन्ट्रेशन ऑफ वॉटर. सो दॅट्स वाय मॉलिक्युलॅरिटी ऑफ रिॲक्शन इज 2 बट ऑर्डर ऑफ रिॲक्शन इज 1. व्हॉट इज फर्स्ट ऑर्डर रिॲक्शन? द रिॲक्शन इन विच रेट ऑफ रिॲक्शन डिपेंड्स ऑन कॉन्सन्ट्रेशन ऑफ ओनली वन रिॲक्टंट. इट इज नोन ॲज फर्स्ट ऑर्डर रिॲक्शन. सो व्हॉट इज द एक्सप्लेनेशन? द रिॲक्शन वॉज एक्सपेक्टेड टू फॉलो द सेकंड ऑर्डर कायनेटिक्स. However, it obeys the first order. The reason is that solvent water is present in large excess. The rate does not depend on concentration of water because its concentration remains constant. So therefore, concentration of water is equal to constant, that is indicated by K double dash. So therefore, rate law becomes rate is equal to K dash into concentration of CH3COOCH3 into K double dash, because K double dash means concentration of water. So therefore, rate is equal to K into CH3COOCH3 because K is equal to K dash into K double dash. Okay, so the reaction is thus of first order. So that's why this reaction is a first order, because the rate of reaction does not depends on concentration of water. It depends on only concentration of methyl acid.